This is the age of dividing people into categories in non-traditional ways. People used to divide each other by skin color, country of birth, gender, and so on, which of course still exists. But as more and more people realize that these are absurd categories, and as more and more people are confronting the problems created by this discrimination, it is no longer possible to do this openly. Today we're going to look at another method of categorization that comes up a lot: the distinction between left-brained and right-brained people. The argument for this is even worse. It claims that we can divide 8 billion people into left, brain-dominant, and right, brain-dominant, and right brain-dominant. Indeed, open any superficial popular science book today, for example, self-help books, marketed under the guise of neurobiology. It is explained that left brain-dominant people are more rational, more mathematical, more scientific. Right-brained people, on the other hand, are said to have developed skills such as attention, orientation, memory, problem-solving. So, for example, scientists are left-brained, artists are right-brained. Which one are you? Now let me say that yes, there is a condition called lateralization in the brain, or more technically lateralization. This means that certain functions can only be processed in one hemisphere of the brain, or at least processed more intensively in one of the hemispheres. For example, the movements of your right arm and right leg are controlled only by your left brain, and vice versa. The left side of your body is controlled only by the right brain. Light waves falling on the left half of both of your eyeballs are processed in the right brain. Light waves that fall on the right half of both are processed in the left brain. In medicine and biology, this X-shaped displacement is called decussation, because in Latin the letter X corresponds to the number 10, and the number 10 is pronounced deca. It's a fancy way of saying crossing, the nervous system organization that occurs as a result of this crossing. We call it contralateral brain organization, and this is the case in all vertebrates. But there is no such crossing in the nervous system of invertebrates. So something must have happened in the species that are the ancestors of all vertebrates after the vertebrates split off from the invertebrates. Whatever it was, all its descendants inherited it, and we humans, as a vertebrate animal species, inherited this opposite brain, body control. We don't yet know exactly what caused this, but the most prominent hypothesis is that this teddy bear is an embryo that is not yet fully developed. So right now, this teddy bear has a head and everything. But imagine that this part of the head is not the head itself, but where the head will develop in the future. The eyes, the nose, the mouth, and so on are not yet developed. We're talking about the very early stages of the embryological period. In vertebrates, there are certain factors that determine how the body develops in the egg or in the womb. For example, in fish, the first ancestors of all vertebrates, including us, and in the amphibian descendants of those fish that later came to land, one of the factors that determine where in the body and which organs and structures will develop in the egg is the distribution of yolk, which we call the yolk in chickens. Where this yolk, the main source of nutrition for animal embryos, is less concentrated in the egg, the head, or anterior side of the body develops. Where the fat is more dense, the posterior side of the body develops. For ease of explanation, whichever side the fat is on, the ventral side of the body, i.e. the abdomen, should face towards it, and the dorsal side, i.e. the dorsal side, should face away from it. Let's take it like this for now. Now let's say that the fat is on the lower side, so the body starts to develop with its back facing upwards. As I said, there are almost none of the organs yet, so there are no arms, head, legs, etc. We are at a very early stage of development. For some reason, and it could be mutations, it could be a chromosomal change, it could be a transpositional change, it could be a transpositional change, it could be anything. The axis of development deviates and the body turns with the left side facing the fat. But this is a problem. Because all vertebrates are bilaterally symmetrical animals. And this symmetry is on both sides of the anterior-posterior plane that runs from the mouth to the anus. For some reason that concerns us, the axis of development has turned, but the fat is still here, down here, and what triggers symmetrical development in these animals are both the chemicals in the egg and the chemical signals that the first few thousand cells that make up the embryo scatter around. According to these signals, the cells exhibit a behavior we call migration. and they go to the places where they should be in the body. So the cells continue to produce signals according to the precipitation and try to put this sideways body back into bilateral symmetry. Especially since, as I said, we're talking about fish, animals that live in water, species where bilateral symmetry is a matter of life and death. So getting back to symmetry is extremely important, and there are two ways to do it. Either the embryo will rotate in the opposite direction and come back the way it was, or it will continue to rotate in the same direction and the body will be in the opposite position. So the abdomen stays on the side away from the fat, and that would ensure symmetry in the head-tail orientation. So, according to the axis twist thesis, both of these rotations happened in the ancestors of vertebrates, but the head and the rump followed opposite directions during this return to symmetry. The head cells turned up in response to the signals they received. The ass cells turned down. So there was symmetry throughout the body, but there was a knot in the body. But remember, in reality, there is no head, no body. We are talking about an embryo stage where there are only the precursor cell clusters that will form them. So there's no such thing as tangling headphone cables or turning your head 180 degrees in the opposite direction. And another thing that this teddy bear misrepresents is that this knot is in the neck. Actually, in the embryo, this knot is more at a higher point. It happens in the center of the head. For anatomy buffs, in the embryological process, there is an opposite twist on the rostral and caudal sides of the area where the head will form. So if the sensory organs are not yet developed at this stage, why are the nerves crossed? Because, for example, the optic nerves start to form in the retina. Then their signal transmitting axons develop towards the front parts of the brain and connect to the brain. If the head had never rotated, the nerves that start to develop from the left eye would have connected to the left side of the brain by following the cells that emit different signals depending on the protein codes in their genes. The nerves developing from the right eye would connect to the right side. But since there was a rotation in the embryological stage, the signals directing the nerves emerging from the left eye come from cells that remain on the right side beyond that node. And therefore the nerves emerging from the left side connect to the right. And the nerves that develop from the right, because the cells that normally secrete signals that would normally direct them to the right remain on the left after the twist. They head there and connect to the left side of the brain. Events. Anyway, as a result, yes, there have been actions in the brain. That is obvious, but this does not mean that we are divided into two as left-brained or right-brained. Look, it is very important to understand this, because starting from the earliest stages of education until adulthood, we impose a lot of nonsensical distinctions on people such as numeracy and verbalism. There is no such thing. Biology and psychology are not that simple. First of all, if the two hemispheres of the brain could not communicate with each other, I would understand this effort to make a distinction. There is gray matter and white matter in the brain. The white matter is a part very rich in axons, which is the part of the nerve that transmits information most intensively in neurons. And where this white matter is most dense is a region called the corpus callosum. And this is a huge neural highway of 200 to 300 million axons. Every second, trillions of signals are carried in both directions. So we cannot think of these two hemispheres as different organs. They are two parts of one organ. Are the chambers of the heart different organs? No, they are not. It's the same with the brain. But we need to understand why this misconception arose. Since the 1900s, in the field of neuropsychiatry, this corpus callosum region has been surgically cut off, especially to relieve seizures in patients with severe epilepsy. Thus, the left and right cerebral hemispheres became unaware of each other. Neuroscience experiments in these so-called split brain patients have allowed us to discover many things about the brain. For example, this was one of the ways in which we were able to discover which functions are processed in which part of the brain. I'll be doing more videos on this in the future, but there are also the ablation experiments, which are both disastrous and tremendous. During brain surgeries that don't use general anesthesia, that is, when the patient is awake, you use a small electrode to touch certain parts of the brain and give an electric shock to these neurons, temporarily silencing them or stimulating them depending on the intensity of the electricity. Then you observe the changes in the person. Today, these experiments are no longer done for ethical reasons. But in the 20th century, studies on this subject helped us a lot to understand how the brain is divided into compartments. I've said this before. Imagine that by silencing one part of the brain, I can take away your ability to conform to social norms. I can activate any muscle in your body. I can take away your ability to speak and give it back. If I wish, I can take away your ability to form sentences only according to the rules of English, or I can take away your ability to make sense of the sentences you hear. I can turn your consciousness on and off like a light. This is all due to the fact that certain functions are localized in certain areas of the brain. But this is not enough to distinguish between right-brained and left-brained, because this distinction is absurd. Look, for example, we say that language is processed on the left, that is, on the analytical side, right? But isn't the effective use of language really about art and creativity? What is analytical about language? What is mathematical? We also say that left-brained people are good at math. But is the science we call mathematics only about doing operations like a calculator? In order to make mathematical discoveries, we need a great creative intelligence, a very comprehensive relational analysis ability, a very good sense of orientation. All of these are processed in the right brain. We say that mathematics cannot be done with only one brain, or that things like painting and music are done with the right brain. Have you ever studied something called music theory? Calculus is child's play compared to it. There is a great mathematics, a great pattern analysis underneath, or Renaissance artists taking the golden ratio as the center, Mimar Sinan's geometric domes, painters using an ancient camera, a camera obscura, to reflect the geometry of nature on canvas and paint it. These are all mathematical operations that are supposedly associated with the left brain. So I don't know about postmodern art, but the left brain is essential for the first things that come to your mind when you think of art. For example, if the left brain controls the right side of the body, which is true, and if 90s of all people are right-handed, does that mean that 90 of us are left brain dominant? Of course not. For example, we've just seen it. We know that language is processed in the left brain. You see that in 10 of right-handed people, language is processed in the right brain. In half of left-handed people, you cannot even attribute language to one hemisphere. It is processed in equal amounts in both. You see, it's as if this left brain right brain distinction was made not by a scientist, but by an 8-year-old child who doesn't know anything about the world. The claim that people are right-brained or left-brained is rather an oversimplification. It's an attempt to trivialize neuroscience. Indeed, to date, whenever we have put this claim of left brain, right brain dominance to the tests of science, it has never passed those tests. That's why among neuroscientists, it's a joke, an example of ignorance, but personal development sells. Therefore, the merchants of hope who claim that they can easily divide people into categories and find simple solutions to their problems through those categories continue to eat the bread of this lie. In closing, let me say that this kind of thing usually stems from first establishing the categories in the head and then inventing data to support it. These things do not start from data and then try to determine categories. There is already a template they want to fit people into from the beginning. Once they have identified it, they make up lies, thinking that whatever kind of fairy tales we tell, we can make people believe that they fit into those categories. As I said, we will go into all this in the following videos. If you don't want to miss it, you know what to do. But for now, let's end this video here. The brain is such an awe-inspiring organ that this kind of trivialization annoys me, as you can see. I wanted to share this with you, and I hope that this video has helped you to understand the very interesting crossover process in the embryological development of the brain, as well as brain lateralization and compartmentalization. See you in the next video. Bye.